This is Mr. Russo, and today we're moving on to day 7 exercises. We're going to be changing or transitioning from solving absolute value equations and inequalities, and we're going to be moving into finding the x and y intercepts of trinomials. I'm going to go ahead and start off by telling you that this will involve some factoring. So let's go ahead and get started here. What we have is we have a trinomial. It's an equation. It's in the form y is equal to x squared plus 30x minus 64. And I want to point out that since we're beginning, Mr. Russo has picked trinomials where the leading coefficient here is a 1. Okay, so they will get more difficult. I will be using trinomials that have leading coefficients higher than 1, but I won't move on to those without reviewing how to factor using magic x. So in order to do today's stuff, I'm going to be doing basic factoring where we just take the C term right here and we just list out all of its factors and we find a pair whose sum and difference is equal to 30. So you'll see that in a second. We did cover this material, although it was back, I believe, during time. So I know it's been a minute. But just to let you guys know, this is the topic for the next 2 weeks. So whenever you have a quadratic equation, and you don't have to graph these in order to find the x and y intercepts. I want to stress that. Okay, you do not have to graph these. You do not have to graph these in order to find their x and y intercepts. We are going to be finding the x and y intercepts algebraically, not graphically. But I want to show you, for the sake of understanding what we're actually doing here, where the x and the y intercepts are on a graph. So let's go ahead and take the equation that we have right here. And if we were to have a graph, then the x and y intercepts would be, okay, the x-intercepts, there would be 2 of them. There would be one right here, and there would be one right here. So these are called x-intercepts because they're at the spots where the graph crosses the x-axis. And what do we know about the y value at these positions? Well, the y value at these positions is always equal to 0. Their height is always equal to 0. And for quadratics, right, for trinomials, you're going to have 2 of them. Now for the y-intercept occurs down here at the lowest, usually the lowest point, although it's not always the lowest point, but it's the spot where the graph crosses the y-axis. So what do we know about the x value, right? The x value at the y-intercept. Well, we know that x has to be equal to 0. All right, so what we're doing here to find the y-intercept, right? The y-intercept is going to be where x is equal to 0, and the x-intercept is going to be where y is equal to 0. Right? So I'm going to go ahead and take this equation right here, and we're gonna go ahead and I'm going to move it to the next slide here, and we're going to find the x and the y intercepts algebraically. Right? I think we can go ahead and get rid of this. All right, so just like with the last topic, I'm going to be splitting this up into 2 different directions. So I've given you 3 problems right here, 1, 2, and 3, and you'll notice that they all have leading coefficients of 1, which should make your factoring a little bit easier. And what I'm going to do is I'm going to go ahead and split this up into 2 different directions. Right? So over here, we're going to be finding the x-intercept, right? And we know that anytime you want to find the x-intercept, we know one thing. We know that the y value has to be equal to 0 at the x-intercept. And over here, to find the y-intercept, right, To find the y-intercept, we know that the x value has to be equal to 0. Now, when you guys are working this out on a sheet of paper, I highly recommend that you start it out like this. Okay? I highly recommend that you write what the equation is that you're trying to factor first. And then I highly recommend showing that there's an arrow going in this direction to find the x-intercepts, and that there is a arrow going this way to find the y-intercepts. Otherwise, this can get maybe a little bit unorganized. So the first thing that I'm going to do is I'm going to start to find the y-intercept. That's the easier of the two things to find. What I'm going to do is I'm going to go ahead and take what we have, y is equal to x squared plus 30x minus 64. I'm going to rewrite it right here. Y is equal to x squared plus 30x minus 64. I'm going to use this piece of information right here, x is equal to 0, and I'm going to go ahead and I'm going to plug in a 0 everywhere that there is an x. I'm going to plug a 0 in there. And I'm going to figure out, by evaluating it, what the value of y is going to be equal to. Right? So I'm going to go ahead and do that. Y is equal to, in this case, 0 squared plus 30 times 0 minus 64. And there's some pretty basic, easy math going on here. We know that 0 squared is the same thing as 0 times 0, which is going to end up giving us 0. 30 times 0 is also 0. And then I have this minus 64 over here. And don't forget to bring down your y is equal to. So 0 plus 0 is 0. And 0 minus 64 is y is equal to negative 64. So in order to write what your y-intercept is, right, you have to have this y value, and you have to have this x value, and you make a coordinate point out of it. So the coordinate is, remember, coordinates are always given as the x value comma the y value. The x value is 0, so it's going to be 0 comma negative 64. Right? So we have found the y-intercept for y is equal to x squared plus 30x minus 64. But we're almost there. You know, we're about I wouldn't say 50% way there, but we're pretty close to the point where we're done with this problem. The next part is really similar. We're going to find the x-intercept, and to find the x-intercept, we are going to make use of the fact that y is equal to 0. So in this case, what we're going to do is we're going to rewrite y is equal to x squared plus 30x minus 64, but instead of putting y, we're going to put 0. So it's going to be 0 is equal to x squared plus 30x minus 64. Okay, so you may have, this is the part where we're going to have to factor, right? Remember that when you factor, you're putting it into a form where there's no x squared term. So at the end of this, right, we're going to end up with 0 is equal to a set of parentheses and a set of parentheses. There's going to be an x here and an x here. There's going to be some term here and some term here. And there's going to be a plus or a minus between them. So this is what we're working on right now. So let's go ahead and factor. Let's go ahead and factor what we have here. So I'll remind you guys that when you factor, you're trying to find all the different ways that you can write negative 64, right? So negative 64, what are the ways that we can write that? Well, let's start with the most obvious. To right, it's a negative number, so negative 1 times 64, right? I also have negative 2 times 32. Scroll down a little bit more here. Let's see here. I don't think 64 is divisible by 3, but we can check. 64 divided by 3 No, it's not divisible by 3. So let's try some other ones. Let's do 64 divided by 4. I know it's divisible by 4. And we'll get 16. So I'm going to go ahead and write negative 4 times 16. I know it's not divisible by 5 because it doesn't end with a 5 or a 0. But what about a 6? I don't think it's divisible by 6. It's not divisible by 3. Let's check. No, it's not. What about 7? 64 divided by 7. Oops. 64 divided by 7. Nope. So what about 64 divided by 8? Yep, it's 8. So we have negative 8 times positive 8. And these are only half of the ways you can get negative 64. The other 4 ways are you can make all of the leading numbers positive, right? And then all the trailing numbers would be negative. Okay. And the purpose of this, the reason we listed all these out is because we're trying to find. I'm so sorry about that. I don't know why I keep getting these emails in the middle of my lecture. I guess I just close out Outlook. It wouldn't interrupt. We're looking for, out of all of these pairs here, the pair of numbers add up to positive 30. So take a look at the list here and which ones will add up to positive 30. I'll give you a second to think about it. So if you're looking at negative 2 and 32, you'd be correct. You take negative 2 and add that to 32, then you end up getting positive 30. All right, so what that means is we can take that negative 2 and that positive 32, and we can write that up here. So negative 2 and positive 32. All right, we're almost there. All right. So in order to find the x-intercepts, right? In order to find the x-intercept, we're going to I guess I should write over here that this is the y-intercept. The y-intercept is 0, negative 64. And we're going to find the coordinates, right? They're going to be in xy pairs of the x-intercept, right? But there's more than one of them. There's going to be 2 of them. Remember, on our previous slide, we saw that the curve goes down like this, right? The spots where y is equal to 0, x-intercepts, right? There's going to be 2 of them, right? So we expect there to be 2 of them. Okay, I'm going to show you the easiest thing that you can do to get your x-intercept. You take the factored form of your trinomial, and you take these numbers you found and you just signs. So one of the points, right, the first point is going to be at positive 2, comma, 0. And the other point, right, the second point is going to be at, instead of positive 32, it's going to be at negative 32, comma, 0. So these are the 2 x-intercepts, and this is the 1 y-intercept. So let me go ahead and zoom out a little bit. All right, so I've only given you guys 3 problems. All right, I've only given you 3 problems, and I want to be very clear about what my expectations are. I want this level of detail in your work for each of the problems. I expect that you will view this video more than one time. I expect that you will take notes, and I expect that if you have questions, you will send me an email during my office hours. And I promise that I will give you an honest and accurate reply. I want to see the given quadratic written. I want to see the y-intercept calculated all on its own side of the paper in this format. I also want to see factoring and the 2 x-intercepts written in this format. This is the easiest way to demonstrate to me that you know what you're doing. And if you don't, then we can address that, but you have to communicate with me. I'm available usually pretty much throughout the entire day. Again, just one last thing I'm gonna state here is that, and most of you are doing this, but for the 2 or 3 people that haven't gotten the message, let me go ahead and say that I am no longer accepting work in the form of Google Documents. If you send me a Google document, um, I am going to send you an email saying that in order to receive credit, you have to work the problems out on a sheet of paper and send me pictures. Okay, you cannot send me a Google Doc and expect credit. I will not be giving that. That has been the expectation now for 2 weeks.